Welcome to virtual algebra class. We are going to be solving multi-step equations today. So excited. Welcome Joey, who's with us. Really excited because solving multi-step equations is the culmination of a lot of things that we've been doing. We'll kind of add to this, but and see how this same thing applies in a lot of different ways. But really, this is where we were heading when we talked about simplifying algebraic expressions, when we talked about solving those smaller equations, when we talked about the order of operations. Today's the culmination of all that. Okay, so in order to move on, I have got to remember or remind you of a couple of things we've already learned. So the first thing I'm hoping that you remember is the difference between simplifying and solving. And this is a distinction that not many students make, and that is much to their detriment. This is much of your struggles in algebra class could be because you don't understand the difference between simplifying and solving. So what does it mean to simplify? Joey, I will ask if you remember, but don't feel embarrassed if you don't, because pretty much students always tell me, I don't remember. You remember what it means to simplify?
Do the work you can do and then stop when you run out of work.
Yeah, it's to obey those symbols that you see, and you stop when you can no longer obey the symbols. So to simplify is to obey those operands, those operation symbols that we see. We're putting things together. And yes, I'm kind of using some artistic license with my definition here. That's not the mathematical definition. But we're going to obey those operation symbols that we see. Whereas solving, do you remember what solving was?
You have to come up with an answer when you're solving. There's an equal sign.
Yeah, sometimes there's an equal. I like that. There's an equal sign. Definitely we solve equations. We simplify expressions, but we solve equations for sure. And solving is when we find the value of the variable that makes things true. And so far from what we've learned, we do that by isolating that variable. That's getting that letter alone. Okay, so we're going to use both simplifying and solving today. We're going to see how they both actually are two sides of the same coin. So we're going to look at that. The other thing that I need to remember is the order of operations. Okay, so we talked about the order of operations as being a four-step process. Do you remember the four steps?
GEMA, groups, exponents, multiply and its inverse, and addition and its inverse.
Beautiful. It's like Joey's been showing up to class, y'all. Take note. Okay, so that's the four steps in the order of operations. And I just would like to remind you that we learned that you work GEMA, or those four steps to the order of operations, forwards when you're simplifying. But when you're solving, since what you're really doing is like undoing your simplifying, it's like working backwards, you're actually going to also work the order of operation backwards. Okay, so we just have to know all these things right now, and we're actually going to put together all the skills we've learned. So for anybody who hasn't seen, doesn't understand the difference between simplifying and solving, or doesn't know the order of operations, you should go back and check out the old videos. But for those of us who do, let's go ahead and forge on. We're going to use this for new and greater purposes today. So here's the big idea for today. The big idea for today is that, remember that all an equation is, the definition of an equation, and those were the things we solved, was an expression equal to another expression. Two expressions that are equivalent make up an equation. Well, the deal is we know that we can simplify expressions and we can solve equations. And today we're going to see problems where we do both. So the basic idea is you can simplify the left-hand side of an equation is an expression. So you can simplify the left-hand side. The right-hand side of an equation is also an expression. So you could simplify the right-hand side. And then when you want to start moving things back and forth across the equal sign, that's when we start busting out our solving skills. Okay, so if we understand that, we can simplify the left, we can simplify the right, and then when we want to start crossing that equal sign, we're solving, and we can do as just about as complicated as these particular types of equations. They're called linear equations, by the way. So the rest of you were not privy to this conversation, but Joey and I looked at quadratic equations earlier this morning. Not the same methods, but these are linear equations when there's no exponent on the variable. Okay, there's no exponent on the variable. So this will always work for us. We can simplify the left-hand side, we can simplify the right-hand side, and then we solve. Okay, so that will be our big idea. The big idea is your life is going to be easier if you simplify before you solve. Now, I have to tell you the truth. This is just a wisdom principle. As long as you are doing something true, you won't go astray, but you might get really messy. So this general wisdom principle of simplify before you solve will just make things neater and nicer. It's not necessarily like there's only one right way to go. In fact, with some problems, there's multiple ways that you could go, okay? But I'm going to apply this general wisdom principle that will simplify the left and right-hand sides before we solve. Okay, let's just try a bunch of examples. Here we go. I have a very simple example. Here is a equation that we could solve, okay? And with this particular equation, I see some simplifying I know how to do on the left-hand side. Can you see that those are like terms?
Mm-hmm.
Yeah, so the idea is we know the simplifying we can do in algebra. Okay, right now, the things that we have at our disposal are the distributive property. That's that idea that multiplication passes out. And we know how to combine like terms. There's plenty of other things you can do, but those are the things we've learned. So those are the tools in our toolbox. So right there, I see some like terms I can combine. So by all means, simplify before you solve. If there's any forwards work you can do, if you can obey the symbols, do it. I can take 2n away from 4n. I would have 2n left. Does that make sense?
Mm-hmm.
Okay, and now, of course, there's nothing I can do on the right-hand side. There's no operations over there, so there's no simplifying to do. Okay? So I've now finished all the simplifying I can do, and so now it's time to start solving. So take a look at this. I can't multiply together 2 and n because I don't know what n is, and so my only option is to work now to get n alone. I'm going to make the 2 move away. And of course, as always, when we're solving, we do it by doing the opposite. So this 2 and n are multiplying together, so I'll divide away that 2. And as we know, when we solve, we do that to both sides. Simplifying is only one side. Solving is a two-sided action. Does that make sense?
Mm-hmm.
So I solve on both sides. 2 divided by 2 cancels. And I'm left with an n on this side. And of course, 4 divided by 2 is 2. And I'm done. I know I'm done because the letter is alone. Very simple little example. We good with that?
Mm-hmm.
Let's pick up our game. Try it a little trickier. So let's try solving. Oh, and I will just number these for you, not because they're not in necessarily the order that they're on, but I'm actually working problems from a worksheet that I'm going to post. So you can follow this along step by step if you wanted to check it out. So this is number 3 from the Kuta worksheet I'm going to post. It's the Kuta software solving multi-step equations. Okay, so here is another problem. 3 is equal to x plus 3 minus 5x. And because of that lovely wisdom principle, simplify before you solve, I will ask you, do you see any simplification that I can do in this problem, Joey?
Yes.
Yes, on the left-hand side or the right-hand side?
On the right-hand side.
Absolutely, I see some simplification on the right-hand side. Is that combining like terms or multiplying? What are you seeing that I can do?
Combine like terms.
Exactly. There's an x and a negative 5x. Those can combine. So let me go ahead and do that. So on the left-hand side, there was no work to do, so it'll stay the same. But if I had an x and I take away 5x, I'll get negative 4x. Combine those. Now, there's nothing I can do or combine with those plus 3, so it'll just drop down. Are you okay with that? Cool. Is there any more simplifying that I can do?
Nope.
No. So it's time to start solving. And this is a two-step equation, which we've seen before, so I will go through it pretty quickly. I will first take away anything that's adding or subtracting, since when I solve, I am working my PEMDAS in opposite order. On this side, 3 minus 3 is 0, and students ask me all the time, can you do that? Yeah, you can do that. If there's nothing left on the left-hand side, the left-hand side is 0. That's a legit number, okay? And then on this side, yes, plus 3 minus 3 turns to 0, but I don't have to write my 0 down because I still do have something on the right-hand side. That's my negative 4x. Does that make sense? Okay, for my final step, I will divide both of those by negative 4. And of course, 0 divided by anything is 0. So 0 is equal to x. And in this particular case, x is just 0. 0 is equal to x, x is equal to 0, same thing. My letters alone, so this thing is solved. Is that good?
Yep.
Step it up. Let's get harder. They're usually 5-step equations that I've seen on the GED. So we do have to get to this slightly trickier level. Okay. So the next one that I want to look at is number 10 from this worksheet. And again, I'll be posting a worksheet so you guys can follow along with these explanations. Try it on your own. Once again, I have an equation. I have, hey, Joey. I think I'm going to ask you to turn off your mic because the background is really loud. Can you just mute yourself until you want to talk? Yeah, and then when you want to talk, you can just unmute, okay? So if we take a look at here, the question again is, do we have any simplifying we can do on the left-hand side or the right-hand side? And you could just nod if you see some simplifying. You might not know because you missed last class. So there's some simplifying I could do on the right-hand side. Right here, this is an act of multiplication. I have 3 timesing by everything in the parentheses. So can you see that that's multiplication even if you don't know how to do it? Wonderful. Oh, cool. She said, Joey says, I was going to say that. Okay, so let's go ahead and do this act of multiplication. Now remember, multiplication has always and will always pass out. So first I'm going to take 3 and multiply by that negative 6n. And you just can multiply together the numbers. So 3 times negative 6 is negative 18. And put the variables on the back end when you multiply. Now, I've passed out my 3 to my negative 6, but remember that 3 needs to pass out to every term in the parentheses. That's what that distributive property said, that multiplication passes out. So 3 times negative 5 would be, of course, negative 15. Okay, so I did that act of multiplication on the right. There's nothing to do on the left. So Joey, is there any more simplifying that I can do? You're right. And so it's time to start solving. Joey shakes her head. No, there's no more simplifying to do. I certainly can't do this act of multiplication, negative 18 times n, because I don't know what it is. And I can't do this subtraction because they're not like terms. It's time to start solving. And remember when you're solving to work that PEMDAS backwards. So move anything, or PEMDAS. Fired! Work Gemma backwards. Old habits die hard. So I'm going to do the opposite of subtracting 15 to both sides. I'm going to add that 15, so that'll zero out. And on the right-hand side, I'll be left with negative 18n. And on the left-hand side, I will have, let's see, 90. Well, my n is not very legible. Okay, now I'm almost done. That negative 18 and that n are shoved up together. They're multiplying. I'll do the opposite of multiply. Since I'm solving, I do the opposite of what I'm told. I divide both sides by negative 18. Dividing by negative 18 and multiplying by negative 18 cancels, so my n is alone, and there's the math to do. Remember, it's 90 divided by negative 18, not 90 minus negative 18. and I get -5. My letters alone, this thing is solved. Is that good? A little nasty. Yeah. Okay. Next example. I want to see you to see how it could get a little funky. It can get a little funky. Okay. I want to look at ones where letters show up on both sides. Okay, we've never seen that before. We're used to our letters staying still and just having to move numbers around, but what happens if we have letters on both sides? So that could definitely pop up on the GED, so let's check that out. So here we have, this is example 11 from the Kuta worksheet, -3 times 1 plus 6r equals 14 minus r. So yes, there's letters on both sides, but I'm still going to start with that first thing, which is simplify. Do any cleaning up that I can do. So do you see any simplifying I can do on the left or right hand side? Yeah, you see that simplifying on that left hand side. We have some multiplication we can do. I see that that -3 is shoved up against those parentheses, so that -3 is multiplying by all that stuff. I know how to multiply. I know how to do that simplification. I'll do it. So -3 times 1 is, of course, -3. And -3 times positive 6r would give me -18r. And, of course, is there any simplifying I can do on the right-hand side? You're right. Those are not like terms. They cannot combine. I'll just drop them. So I simplified. So is there any more simplifying I can do on the left-hand side? No. So I did my first big idea, which was simplify. But now, and I'm pretty much all linear equations, you can follow these 3 steps. First, simplify the left and right. Then make sure the letters are on the same side. This didn't come up for us before because we had problems where the letters were on the same side. But we need the letters on one side. How can we move the numbers away from the letters if the letters are everywhere? Okay, so before we start solving moving numbers around, we have got to get the R terms together. Okay, now notice, Joey, do you see how this R term is on the left-hand side and this R term is on the right-hand side? You can't just combine them. You've got to use that opposite property. You've got to move it across an equal sign. And so I am going to, and you might say, which one should I move? It actually doesn't matter at all. It does not matter at all which one you move. Okay, I'll move the R. I want a minus R to zero out, and so I am going to add R. Does that make sense? Okay, and because I'm moving a term, as you move these letters, you'll always be plussing or minusing because I'm moving the whole term, R and all. Okay, so I'm going to add R to both sides. Notice where I wrote the plus R. Do you notice I wrote the plus R right under the other R term? Because that's who it's going to combine with. Okay, so on the left-hand side, my -3 will still be there, but that's some combining to do right there. -18R plus R, I pay off one of the R's I owe, then I'll only owe 17 R's. And that's equal to, well, on this side, a -R and a positive R would cancel out, so now I only have 14. You good with that? Cool. Now it's just a 2-step equation to solve. So I will begin that process of isolating the variable. Okay, again, you move things that are adding or subtracting first. So I am going to add 3. The opposite of subtracting 3 is adding 3, so that'll zero that out. And I'm left with -17R. Careful, that negative belonged to that 17. It's still -17R. Is equal to, and there's the math on that side, 17. Now, once again, don't be the foolish student who puts plus 17 here. This -17 and this R are multiplying, so the opposite of multiply is divide. So I will divide by exactly the number I want to get rid of on both sides. Okay. On the left-hand side, -17, multiplying by -17 and dividing by -17 are opposites, so they cancel, and I'm left with just R. And of course, if I divide 17 by -17, I'm going to have -1. And now my R is alone. This thing is solved. Are we good? Cool. So you can see that they get uglier, but it's the same skills. It's these same skills we've been doing. We're just having to put together more and more of them. Okay, so let's see if we can make it even grosser. Okay, here we go. Let's try, ooh, 14 looks gross. So negative 16 plus 5n equals negative 7 times the quantity, negative 6 plus 8n, close parentheses, plus 3. Okay, so this is nice and nasty. Okay, so first general rule. Do you see any simplifying? I had a teacher who called simplifying cleaning and packing. Before we start the moving with solving, we better clean up and pack, right? Okay, so do we see any left or right hand side, any simplifying to do? Yeah, absolutely. On that right hand side, we got some simplifying. We are going to need to do this multiplication. Now, don't be the foolish student who multiplies beyond the parentheses. Notice that this negative 7 is shoved up against this parentheses. So that negative 7 is only multiplying by everything in that parentheses. So this and this. Since the 3 is outside of the parentheses, he's outside of the multiplication. He doesn't get involved. Make sense? Okay, so negative 7 times negative 6 will give me positive 42. And since it's leading, I won't write plus because it's leading. There's no reason. Negative 7 times positive 8n is negative 56n. Okay. And then this plus 3 was outside of that action, so it's just going to drop. I have nothing to do with it. Make sense? Left-hand side, is there any simplifying to do there? No, then just drop it. A wise mathematician knows when there's nothing to do. Okay, now looking at this problem, do you see any more simplifying I should do? Absolutely. So remember, when we simplify, we're following the order of operations. So after we're done multiplying and dividing, if there's anything to add, subtract, we've got to do that. And so Joey definitely sees that we have some like terms over here. Like terms, 42 and plus 3. Now, do you see how we're on the same side of the equation? Obey the signs. Don't students start subtracting 3 and doing all kinds of weird stuff. But if I'm on the same side, I'm in the land of simplifying. I need to be obedient. So I'm doing 42 plus 3, and I'm going to get, of course, 45. I still have my minus 56n. I had nothing to combine with, so it just drops. And as Joey told me, there was no simplifying to do on the left-hand side, so I leave it like that. Okay, glorious. Is there any more simplifying I can do? No. So it is time to start solving, but do you see my problem? There's letters on both sides. How can I move the numbers away if the letters are everywhere? And so it's going to be important that I get those variable terms together to the same side. Now you might say, well, which one do I move? Should I subtract this 5n from both sides? Should I do that? Or should I add 56n to both sides? Should I move that one? And the answer is whatever you like. You'll get the same answer. You like 5? 5 is easier. Joey says 5 is easier. Now you might say, hey, I think 56 is easier. Then you move 56. I don't care. See that we'll get to the same place. So Joey likes to move 5. So 5 is currently adding. And so to get rid of him, to make him zero out, I'm going to subtract 5n. Notice I'm not dividing because I'm not breaking up the 5 in the end. I'm moving the entire term of plus 5m. So I have to subtract. Does that make sense? Cool. So I'm going to subtract 5n from both sides. And notice where I put it. I put it right under the one that it combines with so that I make my life easier and I don't screw up. So on this side, plus 5n and minus 5n zero out so that I have negative 16. And on this side, I haven't changed my 45, but I have given myself more n here. So I had, well, less n, I guess. I had negative 56n, and now I take away another 5n. I'm going to have negative 61n. Gross. But your calculator will do that for you if you're feeling really uncomfortable. Just remember that your calculator can't handle letters. You would just have to do the negative 56 minus 5 in your calculator. Okay. Almost done, almost done. So now that I got my variable terms together, I really can start isolating the variable. And I start stopped taking notes, so I'm just doing that. So this is just wisdom principles. There's not one right way to solve a lot of equations, but this is a good rule of thumb. Simplify first, variables together, and then isolate the variables, okay? So I'm going to work on getting this n alone. I'll move the guy who's adding or subtracting first. So I'm going to subtract 45. Don't be the foolish student who adds 45 because they see the minus in front of 61. 61n is minusing, yeah, but 45 is a positive 45. So I've got to subtract it away. I'm going to do the same thing on both sides. Because I'm now solving, it has to happen on both sides. Negative 16 minus 45 will get me up to negative 61n. And on this right-hand side, if this 45 and this negative 45 zero out, I'll just be left with this minus or negative 61n. So when a 61n has no one to minus with, he's just negative 61n. Okay, so, oh, do you see what I did wrong? Joey, I made a typo. Can you see my typo? I accidentally threw in an n on this side that didn't exist. Yeah, exactly. Thank you. So I'm sorry to everybody. I know it's going to surprise you, but math teachers are human too. I accidentally put an n. Can you see why there shouldn't have been an n there? There were no n's on that left-hand side right there. I was disobedient. But there is an n on this right-hand side, and I want to get it alone. So the opposite of, the opposite of multiplying by negative 61 is dividing by negative 61. So I'll do that on both sides. And now I am dividing this time because I'm trying to break that bond between negative 61 and n. I'm not trying to move the whole term, and that's why it's division then. Okay, so negative 61 and negative 61 cancel, so that n is alone. And of course, if you take a number and divide by itself, I don't care how ugly that number is, you get just 1. And my letter's alone, so this is solved. Yeah. Okay, see, they could get a little gross, huh? Okay, I'm just going to do one more example. Let's get the grossest we got out for us. So, I see some serious disgustingness on the bottom of this page. I'm going to try number 19. And I haven't done this before. No, I lied. Let's get even grosser. Let's do 20. 20 is as hard as it gets. So obviously, if you're working these on your own, watch the video by all means, but try working it yourself and then going back and looking at the video to see how you did it. Remembering, though, if we do things slightly differently, as long as we do true things, we'll both get to the same answer. Okay, so I have negative 11 plus 10 times the quantity of p plus 10 equals 4 minus 5 times the quantity of 2p plus 11. Whoo! That looks gross, doesn't it? Okay, so where do we start? We start by simplifying, doing any forwards math we know how to do. Clean it up and pack before we start moving. It'll make our lives easier. So do we see any simplifying we can do on the left-hand side? Me too. So I see that multiplication. Remember to work multiplication before you work addition subtraction since we're simplifying. I see that this positive 10 is multiplying by everything in that parentheses. So that is what I will do first. So I won't touch my negative 11 because it's not in that act of multiplication, but I will multiply positive 10 times p, and so I'll get a plus 10p. Does it make sense that I need that plus in front? Good. And then I'll do my positive 10 because multiplication passes out times my positive 10. So, of course, it'll still be positive, and 10 times 10 is 100. Good with that. Do you see any simplifying I can do on the right-hand side? Absolutely. We have multiplication again. Now, here's my fair warning for you. Here's where students screw up. That is a minus 5, but it's also a negative 5. So when you're multiplying, when you're adding and subtracting, you look at it like a minus 5. But when you're multiplying, you look at it like a negative 5. So that entire negative 5 is multiplying by everything in the parentheses. Does that make sense? Gorgeous. So my 4 wasn't in that act of multiplication, so it'll just drop. Negative 5 times 2p is negative 10p. And negative 5 times positive 11 is negative 55. Are you cool with that? Okay, so we did our distribution. That's what we call multiplication in algebra class, usually. But this is the most common type of multiplication we'll see in algebra class. Okay. That being said, is there any more simplifying I can do? Yeah, we can still combine like terms. We can still do that addition and subtraction. So looking on the left-hand side, do we see any like terms? Yes, there's a constant term and another constant term, two plain old numbers. We can certainly simplify them. And remember, we're working on the same side of the equation right now. We're simplifying, so we're obeying signs. This is negative 11 plus 100. I'm not changing any signs or symbols. Okay, negative 11 plus 100. I'm feeling so slow today. Let's blame it on my new medication. I'm pretty sure it's 89. Yes, I just didn't want to screw it up on recorded. Okay, so I get 89. Okay, now I've got nothing to combine with my plus 10p. I'll just drop my plus 10p. Okay, so we did that combining like terms on the left-hand side. Is it hard to see my plus? Plus. Okay, on the right-hand side, is there any simplifying we can do? Yes, you see it. Again, we've got like terms we can combine. I see a constant term and another constant term. Numbers have always been able to add and subtract. We've always been able to add and subtract numbers since like second grade. Don't suddenly stop remembering how to do that because you're in algebra class, okay? So 4 minus 55, of course, would give me negative 51. And you could, again, feel free to do that in your calculator if you get stumped by negatives. But again, I just obeyed the signs because I'm on that same side of the equation. And I dropped my negative 10p. Okay, cool. Is there any more simplifying to do? No, I did all my simplifying. My left and right hand sides are simplified. And of course, we simplify our right hand side and our left hand side separately. Now it's time to start the back and forth motion across that equal sign. First step, we better make sure that we pick a side for our letters. So what do you want to move, Joey, the 10p or the negative 10p? The negative 10p? Okay, so Joey would like to move the negative 10p, and I asked her because, guys, it doesn't matter. So how am I going to make this negative 10p, this whole term, zero out? I'm going to have to do the opposite of that minusing. I'm going to have to add 10p. Again, I'm not dividing because I'm not breaking up the 10 and the p. I'm moving the whole thing, so it's add, subtract, the whole term. Make sense? Okay, I know I'm repeating myself, but it's because I know the stuff that students get wrong. Okay, so I add 10p to both sides. And I line it up right under like terms to make my life easier. Okay, so on the left-hand side, there was nothing to combine with my 89, but 10p plus 10 more p will give me 20 p's. And on the right-hand side, my negative 10p and my positive 10p zeroed out, but I still do have that negative 51 that I haven't dealt with yet. Cool. So after I pick a side for the letters, I get those variable terms together. It is time to start isolating those variables. And I know you guys are probably sick of me saying this already. Why does she keep repeating herself? I want my voice in your head when you go to take your GED, okay? What's the third step? Oh yeah, isolate those variables. Again, this is just a wisdom principle. These 3 steps are a wisdom principle, okay? They're not the only right way to solve an equation. They're just a good method to go about it when you don't know what to do. Okay, so I'm gonna work on isolating this variable here, get this letter alone. I'm gonna move anything that's adding or subtracting first since I work my Gemma backwards when I start solving. So I'm gonna subtract away that 89. On this side, that positive 89 and that negative 89 will zero out so that I'm left with plus 20p, but since it's all by itself, it's positive 20p, and I don't need to brag about a number being positive. So I'm left with 20p equals, and negative 51 minus 89. Notice when it's in front, I read it as a negative. When it's between numbers, I read it as a minus, will give me negative 140. And I did that in my calculator because I'm feeling so slow today. Okay, now I'm almost done. P's almost alone, but I got to break up the 20 and the p. They're held together by multiplication, so I'll do the opposite, division. I do it to both sides since I'm solving. And I get p is equal to negative 40 divided by 20 is negative 7. Woo! That's as ugly as it gets. How was it? pretty ferocious. So this is as far as I want to go with solving equations. I think I'm feeling done with it. Joey, don't leave me though. I want to tell you one more thing, but for everybody else, I will post this up and I will post the Kuta worksheet with it. So you can try these problems and the rest of the problems. It has answers. You can see how you're doing. You really do need to take it to this level on the GED. And then I'm going to put up one more worksheet, and that one is finding the error in some other student's solving. So sometimes on the GED, they'll give you a 5-step or 6-step equation that's been solved, and you have to find someone else's mistakes. And because there's sometimes more than one right way to go, that's a little tricky. That's a little tricky. So make sure you bring it up to that expert level. You give those kind of trickier problems a try. Okay. So if you have any questions, make sure you email them to me or drop them in the comments if you're watching this on YouTube. Awesome. See you later, guys.